Go from there. So on 37 and 39, there's a trick that occurs that you have to be able to do to make it work. Honestly, we're going to have a hyperbola here because you got a subtraction between the two. But what we need to do is we have to get rid of the numerator. And in order to get rid of that numerator, that's 16, in your mind you're like, okay, I would just divide by 16 and it would go away, or multiply by 1/16. But the problem is, if you multiply everything by 1/16, bless you, this would go away, but then there would be a 1/16 here, and this would be a 1/16 there. Yes, and that's what I'm getting at. Bless you. Because what happens then is that you multiply it by a factor of 1. Now, when you multiply something by a factor of 1, it's basically that. Because what's 1/16 divided by a 16th? 1. So what happens here is that you distribute through. And I'm just going to show you this out in long form. You get 1/16 times 16x squared over 1 over 1/16 times 25 over 1. That's what it would be to that first term. Okay. The second term, well, what's 1 times anything? The other thing, yes, the other thing, the anything. And then what's 1 times 1? 1. So what happens then is that the numerator simplifies, and you get 25 over 16 as an a squared. Okay. That's a little trick that'll occur from time to time. So you wind up with x squared over 25 over 16 minus y squared over 81 is 1. Now, this is an x squared hyperbola, which means which direction it's going to go. Left and right. It's going to go left and right. It's going to do that. And then from there, you can always start out and say, hey, well, a squared is 25 over 16. B squared is 81. Which means a is plus or minus, well, what's the square root of 25 over 16? So it's just a weird way of writing that. So whenever you have a number in the numerator, I think 37 was like that also, as it had a 9. 39 had it like that. You would multiply the top and bottom by 1/9. So that way you'd have a fraction of the one part, but everything else would be the same. It's just a shortcut way to be able to simplify that fraction out by 1. Okay. So from there, you wind up with an a squared value of 25 over 16. B squared is 81. So a squared plus b squared will equal our c squared value. So we just get a c squared that just is kind of awful. So our c squared something ugly. Thank you. Did you see? 1321 over 16. Okay. Hey, is that a perfect square? No. If it's normal-ish number. Like 121 over 9, it should come out as 1/3. But sometimes it doesn't. I don't think 1321 is anyway. We can always check it. So we know that our C value is 9.09-ish. Yeah, it's very, it's ish. And then from there, it's a matter of plotting things through. A values. A value gets you 1 1/4. B value of 9. Rectangle. Or we'll say our C value is way out here and out here. This is one of those that has a very wide. Ooh, I never saw that button. Never used it. Oh, yeah, I don't do that. Does that. Our slopes went up 9 over 5/4. So our slope is 9. So 9 divided by 5/4. You can use this as a complex fraction. This is a complex fraction. It's the same thing as saying 9 divided by 5 over 4, which is 9 times 4 over 5, 36 fifths. So there's your slope. What's that? Yeah, that's how you get the equation of the asymptotes. Whenever we graph these things, and I have to label out whenever we have a hyperbola, you're going to give me vertices, co-vertices, foci, and equations of the asymptotes. Yesterday we talked about, again, I'm trying to adult here, the thing called that lattice rectum. I was wrong. The lattice rectum was not the diagonal part here. The lattice rectum, trying to adult, is the distance between through the C value to the curve. It's that segment length. And we'll talk about that later. This is a little funny. We'll get to it. Don't worry about it. But I know I'm trying to adult. I think it's from Fletch. I want to say it's from the movie Fletch, which I think that's what it was. So other than that, as it gets through there, yes, you get some really crummy values, but it should be okay. Any other questions on those? Yeah. So what you're doing here is you're multiplying everything by you're doing that. You multiply everything. You're multiplying everything by the 1/9. So really, the 1/9 over 1/9. Excuse me. So really, the only thing that changes is the fraction by the y squared. You get x squared over 64 minus y squared over 4/9 is 1. And then everything else works out the same. Hey, let's talk about shifting. All right. So today what I want to do is I want to get into no, know if I want to shift it. I'm going to all think wrong. Let's shift everything. So what I've shown you guys before is that on your calculators in that app thing, we have all of the shifted forms of the equations. So what I want to do here is walk through what they all mean real fast. Guys. Just putting the four formulas up. So as of right now, all the formulas are at your fingertips. Do the values of A, B, and C change? Your A value is still giving you the distance from your vertex, your center to your vertex. Your B value is always going to be the distance from your center to that co-vertex. Your C value will always be the distance from the center to the focus. The only thing that changes now is that our center has moved to an H and a K. So if your center is located at 2, 3, that means your H is 2, your K is 3. The X minus 2, Y minus 3, and so on. Now, don't worry about the one that in the circle form where it has an AX squared, AY squared, BXC, and all that. Don't worry about that. That's not a form that you generally will see. Okay. So what I want to do today is basically talk about how to graph them and how to find parts. Maybe we'll get into how to write the equation, because that's pretty, going backwards is pretty easy. Tomorrow we'll focus our attention on going from what's called that standard form of a conic into figuring out what it actually is. And that's a lot of moving the square. So, excuse me. What I want to do is, like I said, well, you guys are all frantically writing this out. Hey, how about, it's on your calculator, how about this? Tomorrow morning, I will make a printout of all 4 of those for you, and I'll just give you a little small printout, okay? Is that okay? I didn't do that this morning, I didn't even think about doing it, to be honest with you. I'm kind of old and forgetful. What's that? I told you guys I'm not going to make you use the memorize formulas. You? Yes. Merry Christmas. Let's start with this. That's 6. Shifting. Let's start with this. Why is it in a circle? Right. The reason that it's a circle, is because you've got, there's no fraction. Your A and B value are the same. That's something in there. Because if you divide it out by the 16 over to here and here, it would equal 1, but your A and B values are the same. So when your A and B values are the same, it's always going to be a circle. Sorry, something, piece of dust just flew by. So what we do is we write out the equation for the circle to start with. X minus h, quantity squared, y minus k, quantity squared equals r squared. Correct. So where's our h and k? Our center is going to be located at, okay, there's our center. And our radius, you just told me, was 4. Okay. So working with the circle, it's really easy. So now how do you graph it? Nope. Exactly. In order to graph this then, in order to graph this, all we do is go to our center, 3, -2, which is in quadrant number 2. One, little 2, little 3, little quadrants, 4. So there's my center. There's my center. Means I just have to do what again? Move 4 points up, 4 points right, 4 points down, 4 points left. Put a couple of dots. Not to scale. And let's see how close I got with my estimation skills. 3 out of 4 isn't bad. And there's our circle. That's all you have to do. In order to figure out what a circle looks like, that's about it. Okay. It's not bad, is it? It's not bad. Oh no, I made the circle. You just weren't paying attention. No, it's not highlighted. Okay. All right, let's try another one. We'll try another one here. So in this case here, we have quantity y plus 1 squared minus subtraction quantity x plus 1 squared over 4. So when you start looking at this, thinking about all the different equations that we have, which one do you think this might be? A hyperbola? Why do you think it's a hyperbola? Because it has a subtraction symbol in it. Okay? It's kind of convenient. Now, what should I put underneath the y plus 1? A 1, okay. So, oops. Shut. You're such a nice person, all right? I really am. Do you get this kind of abuse out of the classes? I like your parents. They sound like nice people. So, again, real fast, since we're so back and forth on this, y minus 8, it's y minus k. What are you going to screw up here? That. Actually, what you're going to screw up when you have the hyperbola, notice that the hyperbola comes first is the y value. But what's matched up with y? Is h or k? Okay. So I guarantee half of you guys, when you first start doing this, will accidentally write your h value as -1. Oh, well, this is dumb luck, but they're both at 1 and 1. So, but just be careful that your center is at h. Okay, all right. That's a very common thing when you have y squared hyperbolas, or even y squared parabolas, because the k value will be written out first, then you'll accidentally flip-flop your ordered pairs. You'll do everything right, but you'll put it in the wrong spot. Right? So you just got to be very careful about that. So you know that your center is at an h and a k, and in this case again, it is at, bless you, at -1, -1. I know that my a squared value is always the first term in a hyperbola. So my a squared is 1, which means a is plus or minus 1. Your b squared is what comes second, and it was 4. So b plus or minus 4. I'm sorry, plus or minus 2. Your c squared. When you're dealing with a hyperbola, is your c squared found by adding the a and b or subtracting? Adding, very good. And remember the reason why we know that's adding? Exactly. It's the dumb way to remember it, but that's the easiest way to do it. No, I don't mean it bad. I don't mean that badly, but it is the easiest way to remember it. Okay. Now we have enough information to graph this. Okay. So when we go to graph this, we start by locating the center, then we walk back and forth. Okay. So our center, -1, -1. From that, I have to walk on, this is y squared, so this is opening up and down or left and right? It's up and down, so you know it's going to go up, down. So I have to move up and down 1, that's my a value. So that tells me right away that my vertex is at -1, 0, -1, -2. When I get to these, when I get to the shifted hyperbolas, ellipses, and things like that, where I have to list out where everything goes, it's much easier to do them as soon as you plot it, write down where they are. Because once you start plotting everything in there, it gets messy. So it's easier just to kind of separate the steps. Our co-vertex is going to be plus or minus 2, going right and left. So here's 1, 2. So our coverts are going to be at, what is that, -3, -1, 1, -1. So confused, we're just counting. All right? All we're trying to do is just count things out. Now we do our dotted line, very good. Okay. So here's where things get a little interesting. We still find our slopes the exact same way. Okay? We still find the slopes the same way you've done it before. We know that our slope is rise over 1. I went up 1 over 1, 2. So my slope was up 1 over 2. Okay with that? So my slope is 1/2. I don't know for certain if my asymptote went through 0, 0. I don't know if my asymptote went through 0, -2. I need to figure out what its y-intercept is. So this is where you have to use point slope form again. And what you're going to use is you're going to use the ordered pairs at the corners. Because you know what your vertical is there, and you know what your horizontal is where they meet. So you're just going to write out that ordered pair. So in this case, it's at, what is that, 1, 0. And this one is at 1, -2. I know that I have two slopes. I have a slope of 1/2 and I have a slope of -1/2. And I'm going to use that point slope form twice to write the equation of the lines of the asymptotes. You guys know what point slope looks like? Y minus the y sub 1 is your slope of x minus x sub 1. So if I'm using the 1, 0 first, so it's y minus, excuse me, y minus 0 is our 1/2 x minus 1. So it's y equals 1/2 x minus 1/2. there's the equation of the one asymptote. And I do that again with the 1, -2. Y plus 2, 1/2, x minus 1, 1/2 x minus 1/2. Subtract 2, you get, oops. Subtract 2, we're going to get y equals -1/2 x minus 5/2. And those are my two equations of the asymptotes. It takes a minute or two to do that. It is, but remember, getting the ordered pairs isn't going to be terrible because these ordered pairs are where the lines are going through. So you're basically using point slope form to figure that out. Okay, you use point slope form. You can use point slope form with the corners, or actually, if you want, you can use point slope form off the center because isn't that the point that it goes through? Either one will be fine. It's totally up to you. Okay. If you want to use the center for both of them, that might be easier if it's less points to work with, because the line's got to go through the center, doesn't it? So either one is perfectly fine. I know some students like to use that one because when they count their slope, they know what point they're ending on. Because it's easier to do that sometimes. It's totally up to you guys. All right, I leave that up to you. So now we've got those two. We've got the covertex, the vertex, the asymptotes. What are we missing? The focus. So the focus is going to be the C value. That's the distance from the center to the focus. Now, the focus has got to go left and right, doesn't it? So I'm adding root 5 to my center. I'm adding the root 5 to the -1 moving left and right. So root 5 is obviously a little bit more than 2, right? So I would just say it's about here-ish and here-ish. But here's the thing. When I label that, am I adding that to the x-coordinate or the y-coordinate of the center? X, because I'm moving left and right. So here's how you write out that ordered pair. The foci would be located at -1 plus root 5 and -1 minus root 5. All I'm doing is writing it as a complex number. Yes, sir. Oh, sorry. For some reason, I thought that's where I was going from earlier. I forgot we were doing a top-bottom. Sorry about that. And that's the whole reason of writing this down so you don't forget. And Murphy's old and forgot. And now I'm moving up and down. Last but not least, hug your asymptote, go through the vertex, hug your asymptote. Hug the other asymptote, go through your vertex, hug the other asymptote. And you're done. You know, it only takes like 7 minutes. The hyperbola is the one that takes a little bit more time. Ellipses and circles and parabolas are really fast. It's the hyperbola that takes the longest. It'll get there eventually. I dropped this yesterday twice. No, I need to write it down. Never use it. So we've got something here. What is it? It's plus. It's the other one. It's an ellipse, and we know it has to be an ellipse, not a circle, because the a squared and the b squared are different. Now, when we look at an ellipse, we have to take note of where, excuse me, where the larger number is in the denominator. Is the larger number underneath the x squared or the y squared? So which way is it? Up and down again. Stretched up and down because of that. So we have the formula x minus h, 20 squared over b squared, plus y minus k, 20 squared over a squared, where our center is still located at h and k, which in this case is at 3 and, you were saying? -6, very good. So we're at 3, -6. Our a squared value is 49. Our b squared value is 25, which makes our c squared value 24. Very good. Remember, it's the opposite. When you find c squared, it's always going to be the opposite of the sign up there. So our c squared will be at 24. So our a plus or minus 7. 24 is what? 2 root 6? Yeah. Thank you. Which direction did we say this was going? Was it stretched left and right or up and down? Good. Up and down, so hopefully Murphy doesn't make that mistake again. What's that? Oh, that's not killing puppies. That's just that's. So where do you start your graph at? The center, yeah, that thing. Yes. Start at our 3, -6. The vertex goes up and down 7. The vertex goes up and down, up and down. Vertex of the graph goes up and down, unless it's an x squared. Then vertex goes left and right, left and right, left and right. You guys seem to forget my singing is just awesome.
That was
1, 2, 3, 4, 5, 6, 7. So we have to go up and down 7 for our vertices. Remember, all I'm doing is I'm adding and subtracting 7 to my y value at my center, because I'm going up and down. My b value is going to go left and right, so my co-vertex. My k value doesn't change. So we have to go left and right 5. So that's at 8 and -2. Remember, since we're moving left and right, the vertex is going to go up and down. This is going to go left and right. Draw our circle, or oval. Most of your circles will be ovals anyway, so. And then lastly, we have to place our focus in there. The foci, that plus or minus 2 root 6, am I adding that to the x values or am I adding that to the y values? And from the y values. So what we do here at the foci, we know it's going to be shared at the same x value, but our original center was at negative 6. So to that negative 6, I have to add 2 root 6. And to that negative 6, I'm going to subtract 2 root 6. And that's all I do to label the actual ordered parent. I'm not trying to find the actual value, because when I go to plot it, I know that the square root of 24 is a little less than 5. So if I go back up, if I went up and down 7, so here's 1, 2, 3, 4, 5-ish. 1, 2, 3, 4, 5-ish. And I just plot it. I'm doing a rough sketch, but when I do that, all this info is trim. Okay. Which means we have one left to do, the parabola. So the parabola one is a little bit easier. Obviously, there's less work. We have an x squared parabola. So what I do is I reference what that looks like in my calculator. When I reference what that looks like in my calculator, it tells me that that's an x minus h quantity squared equals 4p y minus k. So now we just start piecemealing together. Which direction do x squared parabolas go? Up or down? Y squareds go left or right. So is this one gonna go up or down? It's gonna go up because, like we said a second ago, the p-value here is gonna be 3, since this was positive. So we know that it's going to be an up parabola. We know that our hk is going to be at negative 7 and 3, with a p-value equal to 3. The reason our p-value is equal to 3 is because what we do is we took that 12 equal to 4p. That gives us 3. Now remember, the p-value with the parabola tells you where your center to your focus and then your center to your directrix. That's that distance. So the parabola, when we go to graph this, there's my center. I know it's got to open upward, so the p-value has to move up. So the focus will be 3 above this. So here's your center. The focus is at negative 7 and 6. And where's your directrix going to be located? It's going to be below it. It's going to be at 0, so the directrix is going to be at something equals 0. Now, the directrix is moving from left to right. So, what's the equation of a horizontal line? And that's how we go. Not so terrible? Yeah, that's why I showed that one first. So. Oh, there. Let's do numbers on 628. I just want you guys to grab one of each. So this is 10, 6, 28. We'll do 21, 23, 25, 28. And this marker's dead, so I'll rewrite it. Yeah. Homework that's due tomorrow. Everything up to here. This one we're going to go over. We're not collecting this one, but 10, 2, 3, 4, and 5. No. Tomorrow we'll go over the rough ideas of how those start. Yes. Those four are tonight. Because that'll get us into understanding how do we write equations. We'll probably be able to start on writing equations and completing the square. Or maybe we'll just do completing the square tomorrow and write equations on Friday. It might be easier to do that. Because I think writing the equations is easier than trying to do all the complete square work. So maybe we'll do that tomorrow. We'll see how it goes. All right? So exciting.